right, y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll go over the correct answer. So this is a sum of two cubes, so you're going to use your formula. You'll have 4x plus 1, and then 16x squared minus 4x plus 1, and that would be your answer for your factoring. If you know your formula, it's pretty straightforward. Now on this one, it tells us that angle ABD is 7x, and angle CBD is 3x. Well, those two angles are a linear pair, so they are supplementary. So 3x plus 7x equals 180. So 10x equals 180. So that means that our x value is 18. And it asks for the angle ABD, which they told us was 7x. So 7 times 18 equals 126, which is your B. So that would be the answer for your math knowledge question. Okay? Looking at lesson 78 today, we're looking at the hyperbola, and then we're also going to look at translations of conic sections, which is lesson 106. We're going to combine these two. So hopefully you'll understand the hyperbola, and then you'll understand how to translate conic sections. Your conics would include your circles, your ellipses, your parabolas, or your hyperbolas. Any of those four would be considered conics, but we're mainly going to be looking at circle, ellipses, and hyperbolas. So hopefully you'll understand hyperbolas after this lesson. So the hyperbola is defined to be the locus of all points such that the absolute value of the difference of the distances from any point on the hyperbola to two fixed points is a constant. So back on lesson 71, I think it was, we dealt with ellipses, where the two distances from the foci always added up to be the same thing. Well, when you're dealing with a hyperbola, the two distances, when you subtract them and take the absolute value, they're always going to be the same thing. Okay? So this is what a hyperbola looks like. It kind of looks like two parabolas, but not exactly. The formula is x squared over a squared minus y squared over b squared equals 1. And you have your two foci. This distance minus this distance for every point that you put on your hyperbola, that's always going to end up being the same number. Okay? It's always the absolute value of it. Your A is where your vertex is going to be, here and here. And then your B we're going to use in order to get the graph of the hyperbola, but it's not actually going to show up as your hyperbola, but you will use it to get your graph. So make sure that you draw that picture. And then we could also have it turned so that we have it on the y-axis. Now notice that the a squared was under the x squared, and now it's under the y squared. Your a squared is always going to go with your major axis, just like with the ellipse. Now on this one, we have now, instead of x squared minus y squared, we have y squared minus x squared. Whichever comes first, x squared or y squared, that's the axis that it's going to be opening on. So if x squared is first, then you're opening on the x-axis, and it's going left to right. And if your y squared is first, you're opening up and down. Okay, so make sure that you draw those two. So associated with each hyperbola are two intersecting lines that are called asymptotes. Okay, so we're going to go over, whenever we graph it, how you actually use your asymptotes. But you're going to have two asymptotes that intersect, and that's going to help you graph your hyperbola. The asymptotes of a hyperbola are straight lines that the graph of your hyperbola approaches, but it never actually reaches it. Okay, so we've dealt with asymptotes earlier this year. You're going to have your hyperbola approaching the asymptote, but it's never actually going to reach it. So we want to sketch this hyperbola, and we're going to find the equations of the asymptotes. So what we need to do first is find our A and our B. So our A is coming from this one. It's always going to be the one that comes first now. So our A is going to be 3, and our B is going to come from here, and our B is going to be 2. So just like on an ellipse where you went left and right and up and down, we're going to do the same thing. So on this one, we're going to go left and right 3 because our x squared comes first. So we put a dot, and then we're going to go up and down 2. Now, if it had been an ellipse, there would have been a plus sign here, and you would have just made your ellipse. But it's not an ellipse, it's a hyperbola. So what you're going to do, you're going to make a box, and you want to dot or dash all the sides because it's not part of your graph. It's just going to help you graph it. Now, you do have to have the box whenever you graph it. Don't erase the box, or don't try to erase the box. You want to leave the box because I'm going to be looking for it whenever I look at your graph. Okay? Now, your asymptotes are going to be the diagonals of this box, but they're going to keep going. So it's going to go like this, and it's going to keep going. And then we're going to have another one over here. Okay? So those are your 2 asymptotes, and we'll find the equations of them in a minute. And now we just need to sketch our hyperbola. Well, it's opening starting at this point and this point here on your x-axis, and it approaches the asymptotes, but it never quite reaches it. And so that is what you would put on your test or on your paper for your graph, that whole thing. But only the solid part here and this part here are actually the hyperbola. If you graphed it on the computer or on a calculator, that box and the asymptotes would not show up. But you need to leave them so that you can help me make sure that you did graph it correctly like I showed you to. Okay, so now all we have to do is find the equations of the asymptotes. Well, to find the equation of this line, we're going to go up 2 and over 3. So our slope is a positive 2 over 3. And it went through the origin, so its y-intercept is a 0. On this one, we go up 2 and to the left 3. So its equation is going to be negative 2 over 3x. And the slopes they're not perpendicular slopes, but they are, one's positive and one is negative. But it's the same number there. Okay? So that would be how you graph a parabola and find the equations of the asymptotes. So let's look at another one. We want to sketch it and also find the equations of the asymptotes. So first, we need to find our A. Your A always comes first on these. So A is equal to 2, and our B is going to be equal to 5. So now, on this one, y squared comes first. So that means that we're going to go up 2 and down 2 because we're on the y-axis. And then we're going to go to the left 5 and to the right 5. And now we make our box. Remember, you want to dot your box or dash it. Okay? And you can do your asymptotes. And now it's going to open up and down because y squared comes first, not x squared. Okay? So it's going to open up and down. And it's going to approach your asymptote. You'll see how that works. And so now all we have left to do is find the equations of the asymptotes. Well, we went up 2 and to the right 5. So we would have y equals 2 over 5x. And then we went up 2 and to the left 5. So y equals negative 2 over 5x. So those would be your 2 asymptote equations. Let's look at another example. They give us an equation, and we put it in standard form, find the vertices, the equations of the asymptotes, and we graph it. So the first thing that you're going to want to do is to add the 36, and then you want this to equal 1, so you're going to divide everything by 36. So we're going to have y squared over 9 minus x squared over 4 equals 1. So our a values are going to be 3, and our b value is going to be 2. Okay? So now we're going to go up and down 3 because it's underneath the y, and then left and right 2 because it's underneath the x. And we make our box, and we do our asymptotes. Okay? And now it's going to open up and down again because our y squared came first. And so there's your parabola. That's the graph of it. It also asks for the vertices. Well, the vertices are these 2 points. So our vertices are 0 plus or minus 3, because it's this point here at this point here. And then the asymptotes. Y equals, we went up 3 and over 2, so 3 over 2, and then also negative 3 over 2. And so that's the other information you would need to have. Okay, so that's what lesson 78 is dealing with. Now we're going to flip over to lesson 106, and we're going to look at translations of conic sections. We have already talked about this equation for a circle, x minus h squared plus y minus k squared equals r squared. That is the translation of a circle if it's not centered at the origin. Remember that hk would be the center. For an ellipse, these are the two that you would have. X minus h squared over a squared plus y minus k squared over b squared, or you could have your a squared and your b squared switched around if it is, depending on if it's horizontal or if it's vertical. Okay, so make sure you write those down. We also have the hyperbola, and so it looks very similar to the ellipse. We just have either x minus h squared over a squared minus y minus k squared over b squared, or y minus k squared over a squared minus x minus h squared over b squared. Now remember, this right here is your y value, and this one is your x value. Your vertex is still at hk, but whenever you get them switched around, when the y comes first, sometimes people want to mix up where their center is. So you got to be careful on that. But that's basically the equations there. They all kind of look similar. They all do have the h and the k. And so we're going to look at an example in just a minute of how to use those. But before we get there, we've got the general form of any conic section can be written in this form. Ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. So all of them in the general form would look like that. Now, we are not going to look at ones right now where we have an xy term. We're going to look at the very end of the year where we have an xy term, but for almost everything else that we're going to study, the b is going to equal 0. So you're only going to have those other terms to work with. Okay, so looking at an example. They want us to describe the ellipse that's given by this equation. And so we begin by putting it into standard form. So just like we did with the circle where we had to complete the square, we're going to do the same thing. So I'm going to start by putting my x's together, and then I'm going to put my y's together. And I'm going to make it equal -5. So if I factor out a 3, I'm going to have x squared minus 2x. And if I factor out a 2, I'm going to have y squared plus 4y. Okay? So the number that's going to go here is a 1. Half of 2 squared is 1. But I added 3 times 1 to that side of the equation, so I got to add 3 to the other side. Now here, half of 4 squared is 4, but I added 2 times 4, which is 8, so I got to add 8 to the other side of the equation. Okay, so we're going to have 3x minus 1 squared, 2y plus 2 squared, and then equals 6. So now we need to divide by 6 so that we have a 1. So we have x minus 1 squared over 2 plus y plus 2 squared over 3 equals 1. And so now it says to describe it. So that is in standard form. So to describe an ellipse, we need to tell where the center is. Well, the center on this one is going to be 1, -2. You're going to find it from that 1 and that 2 right there. And then the other thing that we need, is it horizontal or vertical? Well, the 3 is larger, so it is vertical. Our major axis and our minor axis. Are the only things that we have left. So the major axis is found by this 3, and so it's the square root of 3 is our A, but the major axis is 2 times that. So the major axis is 2 times square root of 3, and then the minor axis is found from this 2 over here. So 2 times the square root of 2 would be your minor axis. And so that would be the information you would need to describe that ellipse. Okay? So now let's look at graphing this conic. It tells us to complete the square twice to change it into the standard form and graph it, and it says find the equations of the asymptotes. Well, that means that it is going to be a hyperbola because we have asymptotes. So the way that you're going to do that, you're going to start by grouping your x's together, and then we're going to group our y's together. And then we're going to make it equal 43 by moving that one over there. So I'm going to factor out a 9. So I'm going to have x squared plus 2x. Now on the y's, I need to factor out a -4. So I have y squared, and then I'm going to have a plus 4y equals 43. So the number that's going to go here is a 1. 1 times 9 is what got added to the left side. And then we're going to put a 4 here. So 4 times -4, that was a -16. So I have 9x plus 1 squared minus 4y plus 2 squared, and then equals 36. So divide by 36. And your standard form is going to be x plus 1 squared over 4, and then minus y plus 2 squared over 9 equals 1. So that's your standard form that it asks you to find. And now we graph it. So on these, we go to the center. Our center is -1, -2. Okay? So you're going to go to -1 and then -2. And you're going to put a dot. And now everything else is pretty much like we were just doing. So on our x-axis, we're going to go left and right 2. And on our y-axis, we're going to go left and right 3. So go left 2, and right 2, and then up 3, and down 3. And you're going to make your box. Okay? And now we put our asymptotes. And then we've got to draw in our hyperbola, and it is going left and right because our x here comes first. So it's going to go this way and this way. All right, so there's the graph, and now we found the equations of the asymptotes. Now, unfortunately for this one, the asymptotes are not going through the origin. So you're going to actually have to find your y-intercept after you find your asymptote. After you find your slope of your asymptotes. So the slope is going to be 3 over 2. And then -3 over 2. And they won't have the same y-intercept because one of them is going to hit here and one of them is going to hit down here. And those aren't whole numbers. They may look like it, but they're not. They're fractions. So they both go through this center, which was -1, -2. And so we can plug -1, -2 into both equations to actually find our b value. So -2 equals -3/2 plus b. So if you say -2 plus 3, plus 3/2 over 2, you're going to have -1/2. So your equation would be y equals 3/2 x, and then minus 1/2. And then over here, we can do the same thing. -2 equals -3/2 times -1 plus b. So -2 equals a +3/2 plus b. So if you subtract -3/2, you're going to get -7/2 for your b. So y equals -3/2 x minus 7/2. And if you look at the graph, that's close to -1/2. 1, 2, 3 and a half. That's pretty close to -7/2. But those are the two equations for your asymptotes. So you do have to do a little bit more work there to actually solve for them. Okay? So hopefully that helps you a little bit with the translations of conics and also with hyperbolas. Hyperbolas, they look kind of confusing if you look at the graph, but they're really not that bad. Okay? So make sure that you practice those so that you can get them correct on your test. So your homework is 1 through 30 tonight. Make sure to do all of those, and then we can go over any questions you have tomorrow.